So this is the second video for proportional relationships. And your I can statement is I can identify a proportional relationship and the constant of proportionality. These are some big words, but you already know the math behind the word. We just have to attach what you already know to a new word now. And so let's start with that. Okay, so here's an old input-output table that we've already looked at. You kind of know about this already. You have some inputs or X's and something happens to it and you get some outputs. There's a rule to this table and you've practiced writing the rule. This rule is Y equals 3 times the input or 3 times X. So the output is equal to 3 times X. So this relationship is considered a proportional relationship if the rule is consistent. So if every input is multiplied by 3 to get your output, it's consistent. And if we were to fill in this table, we would see that it would continue to be consistent. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so on and so forth. But if we were to add something that wasn't consistent to this relationship, like 6 and 12, for example, it's no longer proportional because 6 times 2 is 12, 6 times 3 is 18. So this right here broke the rule. So if 6 and 12 was in this table, it would be inconsistent and it would not be proportional. But because it's not in the table, I just added it, we can say this relationship is consistent because the rule is not broken. Something else to keep in mind here is that the constant of proportionality, this other big word, is just the A number. So this 3 right here, that's the constant of proportionality. Constant of proportionality. There we go. And what I think is interesting is these are just big words, but you guys kind of already know what they mean. So quick recap. If the rule's not broken, it's proportional. It's a proportional relationship. Whatever you're multiplying by X or the input to get your output, that's the constant of proportionality. Okay, here we go. Whoops, let's go to our first example. It takes Lee 1 hour to drive 65 miles, 2 hours to drive 130 miles, and 3 hours to drive 195 miles. And the directions say, tell whether the relationship is a proportional relationship. If so, give the constant of proportionality. So, first, we need to kind of make our own little table here. If Lee's driving, it took him 1 hour to go 65 miles, 2 hours to go 130, and 3 hours to go 195, we have to ask ourselves, is there a rule that we can write? Does Y equal something times X? What that something is our constant of proportionality. And if the rule is never broken, this relationship is a proportional relationship. So it looks like we're multiplying X by 65 because 1 times 65 is 65. 2 times 65 is 130, and 3 times 65 is 195. Because the rule is not broken, and we found the rule, it is a proportional relationship, and we know now that the constant of proportionality is 65. Let's do one more example. Same directions. First, we have to figure out, is this a proportional relationship? So let's plug in what we know. Sue types 45 words in 1 minute, 60 words in 2 minutes, and 73 words in 3 minutes. And I've tried really hard, but I can't find a rule for this. There's really no rule. And if there was a rule, like if I said Y equaled 45 times X, it would only work for the first part because 2 times 45 is not 60, it's 90. And 3 times 45 is definitely not 73. So if a relationship is not proportional, this rule does not work. There's no rule that would work. It's not proportional, and therefore we have no constant of proportionality. If it's not proportional, we don't have to worry about a constant of proportionality. Because remember, the constant of proportionality is the A. It's whatever's being multiplied by X. And we just use A to designate, whatever the number happens to be. In the first example, it was 3. In the second example, it was 65. And in the third example, there was none because it's not a proportional relationship. So quick recap. I'm going to come all the way back to the I can statement. I can identify a proportional relationship from here to here. If the rule is not broken, it's proportional. If it is broken, it's not. If and only if a relationship is proportional, then you should have a constant of proportionality. Y equals A times X, or Y equals something times the input. With that said, I think you're going to do very well on the worksheets today. This is probably easier than your input-output table worksheet. Have a lot of fun.